Good afternoon, everyone. Welcome to today's Lucas Systems Perfect Order webinar. Our topic today is double DC productivity without robots or automation. My name is John Schriefer. I'm with Lucas Systems, and joining me today for today's presentation is Steve Urich. Steve is director in our product development group here at Lucas. He's responsible for data science, speech and mobile technologies. So he's the perfect presenter for the topic today. To open up the presentation, Steve is going to talk quickly about some of the productivity challenges in the DC today, and in particular, the way in which excessive travel in picking and other processes impacts productivity. We're then going to quickly review some of the common solutions for reducing travel in the DC. Steve is going to describe Lucas's unique software solution for reducing travel, dynamic work optimization, or as we call it, DWO. Steve is also going to provide a couple of examples of two DCs that have actually doubled productivity using DWO. And finally, again, we'll have a Q&A at the end. And for anyone who may have just dialed in, for the Q&A, you can type in your questions on the Q&A box and hit send, and they will come directly to our presenters here. So now I'm going to introduce Steve to take it away.
Okay, thanks again, John. So with the rise of e-commerce, transformed warehousing over the past 20 years, increasing demands for faster direct-to-consumer shipping. And this has had a dramatic impact on labor demand and costs. DCs today are filling more orders for less than case quantities with fewer line items per order and with shorter shipping timelines. And this is increasing labor requirements. In addition, e-commerce has led to a building boom of new DCs, which has put tremendous pressure on local labor markets, making it harder to hire and retain the best workers. Also, in the U.S., we have the luxury of low unemployment and rising wages. All these factors are putting new pressure on DCs to improve productivity. Now, in most DCs, travel time is the heart of productivity, especially in picking, which is the most labor-intensive process in the DC. In many facilities, pickers spend more time traveling between locations than they do actually picking the product. In some cases, 50 to 70% of total picking time may be devoted to travel. So what about automation or hands-free solutions to address travel time? Well, automation solutions tend to be expensive, and lower-cost productivity solutions like voice or other hands-free technologies don't address travel time on their own. Okay, so let's take a closer look at traditional solutions to the travel challenge. The three options we've listed here directly address the travel challenge in different ways. Let's start with process design. Common process approaches to reducing travel include batch picking and zone picking, which are typically supported by other technologies, including voice, RF, and conventional material handling systems. Next, improved slotting can also reduce travel, both in picking and replenishment, by ensuring the right products are in the right locations, the most convenient locations. However, while slotting is a best practice, it doesn't really get at the core of the travel challenge. Then there's automation, as we touched on a minute ago. Automation takes a different approach by using machines to move product so people don't have to move. And over the years, automation solutions have taken many different forms, such as conveyors and sorters and goods-to-man solutions, including ASRS types of systems and Kiva-like robotic systems. Robotics is getting a lot of attention today as it's seen as a more flexible and scalable alternative to fixed material handling systems. Autonomous mobile robots, or AMRs, are being widely promoted as a solution for rapidly doubling productivity at a far lower cost than traditional material handling solutions. But while AMRs cost less to install than traditional sorters and conveyors and ASR systems, they're by no means cheap, with prices of about $30,000 per robot and with a ratio of 3 or 4 robots per human picker. Okay, so let's look at another approach to reducing travel that can also double productivity, but at a far lower cost than robotics or automation. Lucas Dynamic Work Optimization, or DWO, is part of the Lucas Work Execution solution, which includes Lucas Engage, our server-based work execution software and management dashboards, and also Lucas Move, which is our mobile voice-directed app that features Jennifer Voice. So DWO is a module within Lucas Engage that starts by prioritizing orders based on rules configured for a given DC. It then uses a digital model of your DC to identify which orders should be grouped together in batches to optimize pick density. And finally, DWO then uses advanced search algorithms to create the best possible pick path sequence to minimize travel time for picking that batch. Now, based on customer engagements to date, we've seen that Lucas DWO reduces travel time between 30 to 70% compared to current warehouse management system directed batching and pick paths. As we're seeing our 2 case studies at the end of this presentation, those travel savings can have a tremendous impact on productivity. Okay, let's look closer at batch and path optimization elements of DWO. Most warehouse management systems create batches of orders based on simple rules, such as first in, first out, or earliest gate time by zone or carrier. In some cases, the WMS may use rules to identify pick line or location overlap within orders. But this type of rules-based batching is somewhat limited from a travel perspective, and the FIFO approach is even worse. Dynamic work optimization considers factors such as shipping times and priorities, and it simultaneously applies mathematical models to identify the orders that can be picked together with the least travel cost. The next few screens illustrate the concept using a very simple example. So in this diagram, we're showing 6 orders with each pick line location in the orders represented by colored shapes on the warehouse map. Order 1, for example, includes products at each of the locations marked with the red diamonds. If we were to pick order 1 on its own, the expected travel distance would be 432 feet, as shown. Likewise, a picker would travel 512 feet to pick order 2. But rather than picking the orders separately, batching them together can save significant travel, right? In fact, batching the 2 orders has the effect of reducing the total distance traveled by 25%. But what if we looked at these 6 orders and tried to find the best match to pick with the first order? Here again is the expected travel path for the first order. And if we were to batch order 1 with order 6, we would only add 24 feet to our original pick path for order 1, saving almost 150 feet of travel compared to batching orders 1 and 2. But what if we could look at even more orders? For example, if we consider 10 orders, then there's a greater potential to optimize the batch. In fact, if we were to batch orders 1 and 10, we would add no additional travel cost to the original path. In effect, we could pick order 10 with a travel cost of 0 and obtain an additional 24% travel savings compared to the original batch. This is essentially what DWO does, but it considers hundreds or even thousands of orders and tens of thousands of pick lines in the process. So now let's talk about the other component of DWO, pick path optimization. Most WMS and other picking systems create travel paths that are based on location sequence, typically up one aisle, down the next, without deviation. This leads to a lot of dead travel within aisles. Not only does this hurt productivity, but it's also a strain on your workers who are walking far more than they need to. DWO takes a different approach and applies advanced algorithms to identify the most efficient travel path, while at the same time considering things like one-way aisles and start and end locations within an area. Okay, next, let's see what optimized DWO pick paths look like. To illustrate it, we've developed a simulator that shows DWO paths compared to an unoptimized path based on location sequence. The red dots on the map represent pick locations to be visited, and the blue box on the right-hand side of the screen shows the comparison of DWO path distance to the distance for the unoptimized location sequence path. The first example shows a 31.9% travel savings with DWO. I'll go ahead and play a short video which animates more pick path examples, DWO pick path examples. And as you watch, notice how the DWO path is different than a path based on location sequence. You know, where a location sequence path in this example would start at the leftmost aisle and move to the right in order until the last aisle with a pick is visited. So that's in essence how DWO works to reduce travel through both intelligent batching and pick path optimization. Now let's look at two examples of companies that are using DWO today and with great results. Our first example is a consumer products company that was consolidating distribution from multiple facilities into one centralized DC. In addition to increased throughput, they were also planning to increase the number of different products they were shipping. Before working with Lucas, they were manually batching orders based on ship times and picking 3 to 4 orders at a time. This customer implemented the Lucas system with DWO and a voice-directed picking process. One unique aspect of the DWO solution for this customer is that they needed to apply different batching rules throughout the day. So for example, as they get closer to their earliest ship time, they needed to place a higher priority on picking the orders that need to ship soonest to ensure all orders get out on time. In this way, they get the benefit of optimizing their batches, but also without sacrificing on-time delivery. Right out of the gate, this customer more than doubled their picking productivity, while at the same time reducing errors. In their case, they were able to reduce man hours for picking while significantly increasing their throughput per hour. Our second example is slightly different, as this customer had a variety of different order profiles and customers they were shipping to. And like many other companies here in the U.S., they were also facing challenges hiring workers due to low unemployment. Additionally, they faced accuracy challenges that actually initially led them to evaluate voice technology to improve accuracy over their current RF and pick-to-light systems. This customer implemented the Lucas solution throughout their DC, but DWO is used only in their cart picking area, which represents about 1/3 of their orders. One of the unique elements of their solution is that DWO is building batches for 3 different types of carts based on the number of lines per order and therefore the number of orders per batch. So 3 carton batch, 6 carton batch, and 15 position batch. In terms of their results with DWO, they were able to pick the same volume of orders with half the staff, while at the same time significantly reducing picking errors. So to summarize, DWO is a solution to the DC travel challenge that costs a fraction of robots or other automation solutions, yet delivers dramatic improvements in productivity, in many cases greater than 100%. In addition, DWO doesn't require any changes to your DC or new infrastructure, and it readily scales to support seasonal volumes at minimal incremental cost as compared to the cost, say, of additional robots. Yeah, and so with that, let's open it up for questions.
Great, thanks a lot, Steve. So again, a reminder, we did have a handful of questions, actually a good number of questions come in. If anyone else has additional questions, feel free to submit them via the Q&A box on your screen. So let me start off here. The first question, when does DWO do its calculation? Is it at fixed times during the day?
Yeah, so it's the latter. It's fixed times during the day when a user needs a new assignment. This is by design to give DWO algorithms the opportunity to select from the exact pool of orders in the system at the current moment. We call this DWO's on-demand batching capability. Now, I should note that this doesn't actually come easy. It requires that our algorithms can perform very quickly in real time. So this is not to create a delay when the picker is asking for their next assignment. So.
Okay, so it's basically on-demand batching and pick path sequencing.
Yep.
Okay. Actually, there was a related question to that. We may as well take that one now. Do you need a separate server for DWO to do that sub-second batching?
No, it runs on the same server as your Lucas Engage software, which can be on-site or in the cloud.
Okay, great. So here's a good question. You mentioned that customers are seeing 30 to 70% travel savings, and that's a pretty wide range. And yeah, actually, I've heard that from other people. You're saying 30 to 70%, but how can a given DC get an idea for what kind of savings they might see?
Yeah, so we routinely work with prospects along these lines. We actually have a tool for doing so. How it works is you share with us some historical data on your current batching and travel, your pick path sequence process, say a week or two of such data. And you share things like your warehouse layout and any other rules that need to be respected, such as the prioritization rules we touched on earlier. And with that information, we can run our tool and give you a better indication of the savings you can expect in your specific situation. Now, interestingly, this tool that I'm referring to is nothing more than a front end to the actual DWO engine that's part of the DWO product itself. So we aren't really talking about a simulation here, but rather actual calculations as to the savings you would have achieved if you had been running DWO during those 1 or 2 weeks.
Great. Okay, here's another question. What if we aren't batch picking? Can we still use DWO for pick path optimization?
Yes, good question. So yes, in general, DWO's pick path optimization can be applied, in any situation in which a worker needs to visit various warehouse locations, independent of the style of picking or work type.
Okay. Actually, along those lines, so where do we think people get the most benefit? Obviously, batch picking types of applications, cart picking.
Yeah.
But we have actually had experience with some customers and prospects who are looking at, for example, case picking to pallets. So it's not all each picking.
Right. Yep.
Let's see. Can we use DWO without the rest of the Lucas solution?
So I'll say this, if the opportunity was right, we'd consider it, but currently our DWO technology is available only as an add-on module to Lucas Engage.
Okay.
Yep.
All right, let's see. A couple more questions. Yeah, actually, I'm not sure about this one. So what is the average lines per order where you see the most success? So I would say that it really, it doesn't necessarily matter based on lines per order. For example, I think one of those customer examples, they were doing different types of orders, e-commerce orders, which might have been 1 or 2 lines per order, and then store orders, which I don't know what the actual line counts were, but they just built the batches differently. So I don't know if we can generalize from that.
Yeah, to me, if I'm understanding the question, it's, the optimization is a little independent of that. Of course, the batching logic in DWO will respect lines per order in terms of not breaking up a unit of work across batches. So it will respect those kinds of rules.
Okay. Let's see. Okay, we did get another question. Just trying to read a couple of these questions. Let's see. Yeah, actually, there's another couple of questions regarding using DWO without the rest of the Lucas solution. As Steve said, it is currently an add-on to the solution. Would it be, actually, here's a question. Would this apply for example, replenishment?
Yeah. I mean, again, in the most general sense, wherever there's an opportunity to reduce travel costs, DWO can be applied. Whenever you're moving to different locations, again, independent of the work style or work type. So,
right.
Yes.
Okay. Actually, we did have a follow-up question. So the examples showed multi-line orders, but with 1.1 lines per order, how would you maximize the walk path? I think the objective would be to look at all the one-line, single-line orders and figure out which of those would be most efficient to batch together in a path based on the cart capacity or other requirements.
Right. Yep. And that would actually, lower lines per order actually gives, in some sense, DWO more flexibility in its optimization process, less restrictions in terms of things that have to stay together on the same batch.
Okay, great. All right, at this point, I don't see any other questions. Again, if you do have follow-up questions, feel free to email me at shreve@lucasware.com or to call us directly. I want to thank everyone for attending today, and also watch your email for a copy of the replay as well as a copy of the presentation slides. We are also scheduling additional webinars for next year where we'll be looking at other technologies to improve operations in DCs. So watch your email for upcoming Perfect Order webinars. And with that, thanks very much for joining us and have a good day.